We are going to concentrate now upon the red planet Mars, now brilliant in the evening sky. With me, Paul Abel, Pete Lawrence.
Hi.
The first thing to do is to find it. Pete.
Well, Mars is quite easy to find at the moment, Patrick. It's bright and distinctly reddish in colour. And the way to find it is to locate that very familiar signpost, which is known as the Great Bear or the Plough, or I call it the Saucepan. Well, if you take the two stars closest to the handle, extend them down, you come to a brightish star, which is Regulus in Leo the Lion. You know you've got Regulus because there's a backward question mark above it. Well, Mars is easy to find from there because it's off to the right and it's the brightest thing you can see in that region.
Now I think a few basic facts. First of all, Mars is a planet smaller than the Earth. I've got two globes here to show that. There's
There we
Mars,
go, I'll give you Mars.
Oh, thank you, Pete.
and there's
And
the
I'll
Earth.
be the Earth.
As you can see, Mars is much the smaller of the two, but that means it hasn't got so much gravity. It doesn't pull so strongly. It's got less air. And also, because it's further from the sun, just over 141 million miles, it's colder than the Earth. So we certainly couldn't live there unaided. Nevertheless, Mars has always been the world regarded as the possible abode of some kind of life, and we're still not sure. So there's Mars. Now, having found it, what about using a telescope? You don't need a large telescope. Even with a small one, such as my lovely 3-inch refractor, you can pick up detail. Here's the drawing I made with it.
Yes, I found this in your slide room. This dates back to 1952. And with your 3-inch reflector, you've got some evening clouds on the terminator here, and of course the prominent Syrtis Major marking. And a bit later on, with your 5-inch Cooke refractor, here's some drawings you made of the Solis Lacus region on Mars.
Now, may I look at one of your drawings, Paul?
You can, certainly. Here we go. This is one I made fairly recently, on the 27th January, and the Acidalium region is quite prominent, as is the North Polar Cap, which is quite bright at the moment.
So let's make out just what these features are. First of all, the polar cap. That looks like ice or snow or frost. It's exactly what it is. It's mainly water ice. You expect that. Here we have dark markings, once thought to be seas, but you can't have seas on Mars. There's not enough air. So we now know they're not even vegetation. And that's quite a new discovery, isn't it?
It is, yes, absolutely. The complexity of this region is quite fantastic as well, and you can see when you look at it.
It really comes out well in an eyepiece, but you really need the good seeing to get those fine, tantalising
But
details.
these fine lines which you can see there, you can actually understand why people probably thought there was actually civilization there building something on the surface of Mars.
And of course they change over time.
They do.
Because of the weather, the dust it blows.
We've basically got
the
the sort of lighter regions are the sands of Mars, if you like, the desert areas, and
Yes,
they
indeed.
shift with time, don't they, as the wind blows.
And of course, the seasons are long. Mars goes around the sun in 687 Earth days, a long year, but its day is half an hour longer than ours, so not all that different.
And that's really quite frustrating as an observer of
Yes.
Mars, because when you look at it and then you go out the next day and see it again, you see a little bit round, and then you get a repeat of what you saw the previous
takes
night.
ages to build up. This is about 3 or 4 weeks before you can see the whole Martian surface.
That's
in fact,
right,
isn't
yeah.
it?
So basically, the polar cap is icy. The dark areas are places where the red, dusty stuff has been blown
away, yes.
And those red areas are deserts, but of course they're not like our deserts. No palm trees and camels there.
Certainly not.
They are cold.
They are very cold. And in fact, one of the nice things I think you can see through a telescope, and it really emphasises just what a dynamic, fascinating world Mars is you get these morning and evening clouds over the
they're
desert.
beautiful, aren't
and
they?
when
Really
they
good,
collect
yeah.
around the volcanoes in the Tharsis region, you get this weird W-shaped clouds. It really brings it home to you that this is another world in
yeah,
space.
I completely agree.
It's
Yeah.
a fantastic sight.
Well, a lot of people have been drawing Mars, haven't they?
They have. It's not just me anymore. Loads of people are doing it. This is quite a nice one, I thought.
It
This
is.
was sent in by David Hartley. This shows the Syrtis Major, and we have the North Polar Cap and the Lowell Band. We have another one as well.
We
don't
do.
Pete?
There we go. That's a beautiful image. It almost looks like it's been imaged, actually, photographed. It's very well
It's much
rendered.
better than that, Peter.
I've got some images here which have been taken by amateurs through slightly larger telescopes,
Yes.
sort of ranging from about 10 inches up to
Yes.
14 inches. It's rather unfortunate, but amateurs tend to call this the boring side of Mars because it's just...
Who took that one?
This is Alan Friedman, and
yeah.
I really do like this because
It's a beauty, isn't
it's
it?
a beautifully rendered image.
Look at the detail in the polar cap. Look, you can see because it's currently spring in the north.
Because the polar cap waxes and wanes with the Martian seasons, just as ours does.
And I think it's starting
does.
to break up. Look at the fine structure.
You can
he's got
see it there.
That's beautiful.
You've also got some lovely clouds, of course, visible there as well.
Wonderful stuff.
But I've got a nice little detailed image here from Peter Edwards, which is gorgeous, and it shows the region, which is actually in your drawing.
Yes,
Paul.
they're quite comparable, aren't they?
Well, we're looking at Mars for over 60 million miles, and always from over 30 million. What we need are rocket probes, and they've been sent there. Some have landed, some have orbited, and we had those two splendid rovers, Spirt and Opportunity, crawling around Mars and sending back the most amazing data. Spirit's tail is now stuck, but they've done their work. And Chris, been to America, talking to the key man of the whole program, Professor Steve Squyres. And so now, over to America.
A few weeks ago, I visited snowy upstate New York, where Cornell University is home to a group of scientists who've been on an incredible journey. In January 2004, two remarkable rovers touched down on the surface of Mars. Spirt and Opportunity were only supposed to last for 90 days, but 6 years later, they're still going strong. The rovers are essentially robotic geologists that can move around, take pictures, and analyse rocks to determine their composition, and so build up a picture of the Martian landscape. Spirt landed in a large crater called Squyres, left over from a long-ago meteorite impact. On the other side of the planet, its sister, Opportunity, landed on the plains of Meridiani. Both sites were selected as they looked, at least from orbit, to be likely places to find evidence that Mars was once a warm, wet world. Spirt was the first to land, but quickly discovered that the surrounding rocks were volcanic and had little to say about water. So the rover headed off to the more promising-looking nearby hills. Opportunity, though, hit the jackpot. Right in front of it was an exposed rock face, bedrock, that clearly showed evidence of water. Critically, this is evidence that Meridiani was once a lake or a sea of liquid water, right here on the red planet's surface. Meanwhile, Spirt had heroically climbed up Husband Hill, finding evidence that here, too, water was once common. Opportunity had been travelling too, first reaching nearby Endurance crater and then heading off across the sand dunes to a much bigger crater, Victoria. Steve Squyres has dedicated his career to build spacecraft to land on Mars, and he's led his team on this epic 6-year journey. We started talking where we'd left off on his last Sky at Night appearance, with Opportunity's arrival at Victoria Crater.
Victoria's about 800 meters in diameter, and about 70 meters deep. It's got cliffs on the crater walls that are vertical in places and can be as high as 6, 7, 8 meters. So it's a dangerous place. I mean, it's the kind of place where if we make a mistake, our little rover could fall off a cliff and die. So when we were operating along the rim of Victoria, we had to do so very, very carefully.
Why is Victoria Crater special?
Well, Victoria was the deepest hole in the ground that we had access to. You know, we didn't bring dynamite, we didn't bring a drill rig. We have no way of looking below the surface other than what, looking at the holes that nature has dug for us. And at the Opportunity site, getting below the surface is particularly important because the rocks there are sedimentary rocks and they're flat-lying, they're layered, okay? And the terrain is very flat, and so if you're driving along the surface, you're basically just seeing the same layer over and over, and you don't know what lies beneath.
And that means you're looking at the same time in Mars' history.
You're looking at the same time in Martian history, you're looking at a record of the same environmental conditions in Martian history. You're basically doing the same thing over and over. If you can get below the surface, you go back in time. And Victoria is this huge big hole in the ground.
You did a very long exploration of the rim.
Yeah, we spent nearly a year working our way along the rim. So what you have are these kind of alcoves, and they're just tens of meters away is a cliff.
And so you could do lots of your science.
Exactly. There's like 6 meters of vertical rock there to be imaged. But this is the tricky part. To get the shot you want, to get the image that you want, you need to drive right to the edge. So there was this incredibly intense year where you've got the rover drivers, the engineers, whose job it is first and foremost to protect the vehicle at all costs. And then you've got the scientists saying, just go a little closer to the edge. Just go a little closer to the edge, you know. And there were times where literally we practically had the front wheels hanging over the edge of a cliff to get the shot that we wanted.
Were you always going to go inside the crater? I remember a lot of debate at the time, because what if you got stuck in there? That's it.
Yeah,
that's
we went back and forth on that for a long time. Were we going to go in and take the risk or not? You know, the science return from going in is obviously important, because many of our instruments, you have to reach out and touch the rock.
That's right.
So you got to go down. Yeah, all the instruments on the arm, you got to go into the crater if you want to take advantage of this big hole that we're exploring. But there's the risk that you're not going to get out again. The good thing was that by the time we got to Victoria, we really had a very good handle on what we could do and what we couldn't do. We had operated it on steep slopes before. We were confident enough that we could pull it off.
And so you shuffled down slowly into the crater.
What you do is you're kind of working your way back in time geologically as you go to deeper and deeper and hence older and older layers. And we would just work our way down. And each time we got to a layer that looked different, we would take the instruments on the arm and we would use them to characterize the texture, the chemistry, the minerals that are present, and so forth. And just work our way down into the crater, doing a stratigraphic section. And the thing that was beautiful about that, you know, geologists are big on doing stratigraphy, and a stratigraphic section is just a description of the rocks in a vertical sequence.
As you work down.
Exactly. And, you know, we were incredibly proud of the fact that over at Endurance Crater, the first half year of the mission, we did the first stratigraphic section that had ever been done on another
not just
planet.
picking up random rocks on the surface anymore.
Yeah, we're working our way down very methodically. But now we could do two different vertical stratigraphic sections 6 kilometers apart at Endurance and Victoria, and compare the two to look at lateral variations.
So what story did the rocks in the crater tell you?
What they told us was that the rocks there, as they were at Endurance, are sandstones. The grains of sand are made of largely sulfate salts that were formed when acid groundwater evaporated away and left these sulfates behind. Blown around by the winds, we see marvelous, oh gosh, some of the pictures are just fantastic. In the walls of the crater, we see the ancient remains of very ancient sand dunes that were once present, and you can see that it's called cross-bedding, where there are layers that meet at angles like this, and it's just like from a geology textbook. It's just absolutely fantastic stuff. And then, after the rocks were deposited, they interacted with liquid water below the ground, dissolving away some minerals, precipitating out others, and so forth. And the patterns are very similar to what we saw back in Endurance. So what that says is that it really was regional in scope.
Let me ask you the difficult question. Do we have any idea how far back in time this was?
Oh, I was afraid you were going to ask me that. No, I don't. I really wish I did. You know, one of the most fundamental questions in geology is always, when did it happen? And the way geologists on Earth do that is they either look at the fossils that are present in the sedimentary rocks, which
that doesn't help
we can't do, or they do radiometric age dating by taking the rocks back to a laboratory, and that we can't do either. So I can tell you that the rocks at the bottom of the stack are older than the rocks at the top of the stack, but the absolute ages, you know, I wish we could, but it's just a shot in the dark.
And we're not just talking yesterday, are we? We're not talking millions of years ago.
We're probably talking, billions of years ago, but if you're going to pin me down as at 1.6 or 2.2 billion, I'm going to throw up my hands.
I'll let you off this one. So how was climbing out? Did things go as expected?
It was tough at first. The initial parts of the ascent out of the crater, we had a lot of wheel slippage and spinning, and there were a few kind of white knuckle days in there where we were a little nervous, but we eventually did get out of the worst of it and got back on ground where we had good traction, and out we went.
And then what?
Well, that was the interesting thing. The obvious easy thing to do is just kind of go, noodling around on the planes till the wheels fall off. Or we could try something a little more bold. And more than 10 kilometers off to the southeast, in fact, closer to 20, there is this huge crater that we named Endeavour Crater. We can see the rim of Endeavour Crater on the horizon from where we are right now. We could see it a year ago.
And because it's huge.
It's huge. It's absolutely huge. The rim is hundreds of meters tall. Like 25 kilometers in diameter, hundreds of meters deep. It's not even a crater that was formed in the layered sedimentary rocks. It's an ancient crater, huge thing that predates those sediments, and the sediments were deposited over top of it, and then there's bits of the rim sticking up through the crater. So it's really, really different. And we decided we got to pick some direction to drive. Let's go for that thing. We were talking about more than doubling the total mileage on a 5-year-old vehicle that was designed to last for 90 days and go a kilometer. So let's just say that the odds were not in our favor, okay? But it has just energized the science team, the engineering team. Opportunity is just a fun vehicle to operate these days.
Well, let's swap sides of Mars. Spirit?
Spirit has had a tough time. And about 800 days into our 90-day mission, the right front wheel on Spirit failed, and we have to drag it. So Spirit, which used to climb mountains and drive 100 meters in a sol on a Martian day, a really good day would now be 5 meters. And we would have to drive the vehicle backwards, dragging the dead wheel through the soil, and it was painful. So one day we're driving along through this little valley, dragging our dead wheel. We get to the end of the drive, and we look down at the wheel tracks, and they're as bright as white snow. So that got our attention. We go over, we whip out our X-ray spectrometer, we measure the composition of this stuff. It's 91% pure silica, SiO2. Now, this is not quartz. This stuff is not beach sand. It's basically opal. And there's lots of it. And we never would have seen it if it hadn't been for the dead wheel. That was what exposed it. What we've come to realize is that these silica deposits are the remains of an ancient hydrothermal system. If you go to a place like Yellowstone, where the geysers are, and you look around the geysers, there are these beautiful sort of whitish, bluish rocks around them. Those are silica that have been precipitated out of the water. And you can go to hot springs on Earth, and they're teeming with microbial life. So this was the remains of an ancient hydrothermal system, an ancient habitable environment on Mars. And we found it because of the dead wheel.
So where's Spirit now?
Spirit's stuck. So unless some absolute miracle occurs, Spirit has found its final resting place on Mars. And we transition from being a rover mission into being a lander mission.
It must hurt to have the rover stuck.
I think the day when it suddenly hits us, we've gotten our last transmission from the vehicle. That's going to be, I think, pretty hard. There have been 1 or 2 times over the course of the mission where, major dust storms particularly, where it looked like the power system was just getting so ragged that we were going to lose the vehicle. And so the most likely way in which a stationary vehicle dies is too much dust on the solar arrays, seasons change, and we lose power, we can't keep the thing alive. And I don't anticipate that's going to be a good day. It's had a good life, a good, long, productive life, and it's achieved so much more than any of us could ever have anticipated or hoped for, that if this is the end, it is clearly an honorable death.
Before Spirit can start its new life as a stationary laboratory, it has to survive the harsh Martian winter, which is likely to send the rover to sleep for weeks or even for months. On the other side of the planet, Opportunity is still going strong. It's only just visible amongst the sand dunes on this image, captured from space by the Mars Reconnaissance Orbiter. It'll be a long, hard slog, but 7 miles and thousands of sand dunes away lies her target, Endeavour Crater. Let's hope she makes it.
Well, who knows? In the foreseeable future, astronauts may go there and find Spirit and Opportunity, and they'll wait for us. They know where else to go.
That's very true. And for the amateur in the meantime, there's plenty to do. If you're a visual observer, there's plenty of work to be recording on Mars, and the imaging.
If you've got a telescope with a camera, then go out and grab it now, because it's at its best.
So go out, find Mars, use what equipment you have, and make the most of this opportunity, because it'll be some time before Mars is again really well placed. Paul, Pete, thank you very much.
Pleasure.
Thank you.
Next month, a special program about life elsewhere. So until then, good night.